Meet John. John is a man of few words and many interests. But today, John has a story to tell us. John?
Hi, I'm John. I was walking down the street listening to my Fun Facts podcast. As I was walking, I heard the following tidbit of information. Did you know that as ice cream sales increase, the rate of drowning deaths increases sharply? Therefore, ice cream consumption causes drowning. Oh no. Could this be true? Could my two favorite things about summer ice cream and swimming possibly be the end of me? Am I destined to a long life of heartbreak? What will I do? Oh yes, I know what I will do. I remember a lesson from Chapter 2 Section 7 of my Algebra 2 book titled Curve Fitting with Linear Models. I will conduct my own research and determine if this truly devastating news is false or true.
Well, I believe that is a truly wonderful idea, John. I'll meet back with you in a little while to see how you're doing. In the meantime, I'm going to teach our fellow learners a little bit about this concept you are using. Okay, everyone, let's talk about regression. Regression is the statistical study of the relationship between variables. So, John is going to study the relationship between ice cream sales and deaths by drowning throughout the year. One way he might start doing this is by collecting data on the matter and creating a scatter plot with the data. Just by looking at the scatter plot, we can understand the form, direction, and strength of the relationship between the two variables. The strength and the direction of the linear relationship is what we will call the correlation. These three scatter plots demonstrate positive, negative, and relatively no correlation. And notice that the slopes are also of the same direction. Oh, I just received a letter from John. Let's check it out. Ah, yes, it is the data he must have collected. We have the ice cream sales versus the number of drownings. And what kind of correlation and slope does his research present? Well, what do you think? It is a positive correlation with a positive slope. There is something else we can gather from this data called the line of best fit. We can find this if there is a strong linear relationship between the variables and use it to make predictions. We also want to make sure that there are the same number of points above and below the line of best fit. Let's sketch in the line of best fit with John's data. We will talk about how we can find the equation of this line mathematically in a little while. But before we do, let's look at one more piece of information we can gather from the data. It's called the correlation coefficient, R, which is a measure of how well the data set is fit by the model. In other words, it will tell us more about the strength of the relationship between the variables. When the slope and correlation are negative, the correlation coefficient will be negative. And if the slope and correlation are positive, the correlation coefficient will be positive as well. However, if it seems that there is relatively no correlation, R will be pretty close to 0. Also, the value of R will always be between -1 and +1. The closer that we get to -1 and +1, the stronger the linear relationship. The closer to 0, the weaker the linear relationship. So if we were to estimate the correlation coefficient for John's data, which would you expect it to be? -0.9, +0.2, or +0.8? I would say that R equals 0.8 would be a better estimation of the correlation coefficient than the other options. It cannot be -0.9 because our data presents a positive slope and correlation. 0.2 implies that there is a weak linear relationship, but our data is quite clear in the direction of the relationship between the variables of ice cream sales and deaths by drowning. That leaves us with 0.8, which means there is a strong positive correlation. Okay, let's use a little math now, shall we? We'll get back to John's research in just a moment. In the meantime, grab your TI Nspire calculator if you have one, or just take really good note of what's about to happen on your screen. The gas mileage for randomly selected cars based upon engine horsepower is given in the table. Let's make a scatter plot of this data using our calculators. So let's put our information into the calculator. Start by making sure your calculator is at the home screen and press 1 for New Document. If asked if you would like to save your unsaved document, go ahead and say no. Let's add lists and spreadsheets. Because we're dealing with horsepower and mileage, I'm going to call my columns H and M. I'm going to input my values for horsepower into column A. So I have 175, 255, 140, 165, and so on. Now I'm going to input my values for the mileage, miles per gallon, in column B. Now that I've got all of my values input into my table, we need to create another page for our document. So press Control Doc, where it says plus page above the Doc button. And this time we're going to add data and statistics, option number 5. You'll have a screen that looks something like this. And at the bottom you'll see it says click to add variables. So you'll click, and our independent variable is horsepower. So we'll choose H. And our dependent variable, we will click on the left-hand side until the rectangle comes up over here and choose mileage, M. And there's our scatter plot. So on our calculator, we created a scatter plot and it looked something like this. Now we need to find the correlation coefficient R and the line of best fit. Remember, the correlation coefficient tells us the strength and the direction of the relationship, and the line of best fit helps us to make predictions. To get the line of best fit on your calculator, on the scatter plot, all you have to do is go to Menu, Analyze, Regression, and the first option, Show Linear MX plus B. If you need to, you can click and hold and move the equation out of the way so that you can see it better. So here we have about y equals negative 0.15 plus 47.51. That is the equation for the line of best fit. To find the correlation coefficient R, we need to go back to our list and spreadsheet. You can either click on the 1.1 in the upper left-hand corner to go to the previous page, or you can press Control Left to go to the previous page. So with our information already in the table, to get the correlation coefficient, we press Menu, Statistics, Stat Calculations, and the third option, Linear Regression MX plus B. For the X list, we choose our independent variable, horsepower. For the Y list, we choose our dependent variable, mileage. Press Enter. Now you'll see, if you scroll down, here's our correlation coefficient R with a value of negative 0.916, or about negative 0.92. So, because our line of best fit was about y equals negative 0.15x plus 47.51, that tells us that our slope is negative 0.15. So, for each 1 unit increase in horsepower, our gas mileage drops about 0.15 miles per gallon. Also, because our correlation coefficient is about R equals negative 0.916, this indicates there is a strong negative correlation. Finally, let's predict what the gas mileage would be for a 210 horsepower engine. Because horsepower is our independent variable, we should substitute 210 for X. This leads us to an output value of 16. Therefore, the mileage for a 210 horsepower engine is about 16 miles per gallon. Let's check back with John. what is all of this celebration about?
Mrs. Suderman, I've done it. Here is my research. Yippee skippy.
Well, let's take a look at it. You've written, even though the data presented a strong positive correlation and the correlation coefficient was close to 1, as it turns out, correlation does not imply causation. Just because two variables seem correlated does not mean that they affect each other in any way. In this case, it was because
Both ice cream sales and deaths by drowning rise during the summer. That is when it is hot outside and cold snacks and a swim in the pool are more likely to occur.
well, that is good news indeed, and a good thing to remember. Just because variables A and B have a strong correlation does not, in fact, mean that A causes B or B causes A. So, John, go about your merry way and enjoy those swimming pools with safety and ice cream in moderation. See you all soon. Bye now.